Algebra Chapter 1. I'm going to finish up Lesson 1 by looking at evaluating these algebraic expressions. And there are some very common errors that happen when students are evaluating expressions. And I've listed a few of them here. Misplacing a negative sign, not recognizing all the grouping symbols, doing their order of operations incorrectly, and then a failure to simplify all the way, and then maybe one more we get out in there we talked about before, not putting things in a conventional form at the end. And we already talked about some of the grouping symbols, so we need to recognize those. We have parentheses, braces, brackets, and then that division bar, which is the one that's usually missed. We've talked about PEMDAS and doing the order of operations. What I want to look at now is misplacing a negative sign, and this usually happens again when we're evaluating, when we're substituting now a number in for the letters in the algebraic expression that we're given. And when we start working more with negative numbers in a few weeks, this is going to be a very common error. And a lot of students think they don't get math, and really it comes down to just, we're not just taking care of the negative signs. And if we could just take care of that, we could really be much better at math and maybe not feel so frustrated with it. So I'm going to give you a tip on how you can avoid misplacing a negative sign, and I'm going to require that you do this in order to help that. Now, I don't know how much work you've had with negative signs and adding negative signs, multiplying negative signs, those types of things, but we're going to do a lot of that, as I said, in a few weeks. So we won't be really necessarily doing the types of things where you would lose this, but we're going to practice this now so that when we get there, we have something in place that helps us avoid losing that negative sign. So how can we avoid losing a negative sign? The way we want to avoid losing a negative sign is when we're asked to evaluate an expression, we know that our first step is we're going to substitute in a number for every variable. So all of the letters are going to get a number put in their place. And so what we want to do is we're going to go through and rewrite that expression, and for every letter that we come to, we're going to put a parentheses there. We're not going to put anything in it. We're just going to write a parentheses for the letter. Okay, so that's the first thing we're going to do. Once we've written the expression, we're going to have parentheses. We're then going to go back and put the number that we're given in for each letter inside those parentheses that we've created when we rewrote the expression. By doing that, that's going to help us not lose that negative sign. That's going to be the thing that helps us not lose it. Then once we've done that, we're going to go ahead and just simplify the expression as we did with those algebraic expressions using our PEMDAS. Okay, so for example, let's say we're given the algebraic expression y plus 8, and we want to evaluate it for y equals 9, meaning for every y, we're going to put in the number 9. Now again, and I'll talk about this in a future video, I don't want you to skip this just because it's easy. Okay, we practice with the easy ones doing what we're going to do for the difficult one. That way, when we get to the difficult ones, we've already got the process in place and we know what to do with it. So, the first thing we're going to do is rewrite the expression, y plus 8, and for every variable or every letter, we're going to put a parentheses instead. So we rewrite this as y, parentheses, plus 8. Now we're going to go back and substitute in the number 9 for every parentheses that represents the y. So we're going to go back and we're going to put a 9 in for each parentheses, which gives us 9 plus 8. Now we're going to do our PEMDAS. We're going to go through and simplify. 9 plus 8 is 17, and again our answer is in those braces. Okay, so it's a very simple method for not losing a negative sign. Rewrite the expression using letters or using parentheses for every letter. Then go back and put the numbers in. Do not put the numbers in as you're writing the parentheses. That's where the error occurs. And again, we're trying to avoid that. Not so much for these simple ones. I get it. You could probably do that in your head. Not so much for that one, but for the more complicated ones later. It's very important. Okay? Got to look to the future. Okay? So you can avoid losing a negative sign by rewriting the expression with parentheses, then substituting in the value. Then we can go ahead and simplify the expression. Okay, let me do a few examples for you to try and solidify this idea of avoiding our loss of negative signs as we're working through these. Okay, so we have y plus 24, that's an algebraic expression, and we want to evaluate it for y is equal to 11. So we're going to rewrite this expression, and for every variable we're going to use a parentheses. So we have y plus 24. Now we're going to go back and put in 11 for every y parentheses. So this is 11. And now that I've substituted in the value, now I can simplify. 11 plus 24 is 35. So this would be 35. Okay? Now here we have 4 minus x, and we want to evaluate it for a value of x equals 1. So again, we're going to rewrite the expression first using parentheses for our variables. So it's 4 minus an x minus another x. Okay? Now we're going to go back and substitute in the value that they give me for x. X they want us to put in a 1. So for this x here, that's a 1, and for this x here, that's a 1. And now that they're substituted in, we can simplify. So 4 minus 1 is 3, minus 1 is 2. So this would be an answer of 2. Here we have 4h, so we're going to rewrite the expression 4. There's no operation symbol in between those, so that means it's multiplication, so we're going to use parentheses. And you can put a parentheses around the 4 if you want, but it's unnecessary, but we will go ahead and do that. And now we have rewritten the expression with parentheses, and now we want to substitute in 12 for each parentheses of h. Now that we have this, we can simplify this. 4 times 12 is 48. And finally we have 12 divided by y, or 12 over y, so it's 12 divided by, and then we have our parentheses, and they want us to use a value of 2, so we're going to put in 2. So we then have a 12 divided by 2, which is evaluated for 6. Okay, and again, you're not going to run into too many problems in this lesson. I don't think any problems where maybe you have a negative that you might get lost. This is for future reference, but we practice it with these simple ones so that when we get to the more complex ones, we have a way to deal with it, and we don't try to learn that then along with the complex concept that we're trying to do. That way we'll already have this in our toolbox.